Hello. Get started in just a minute or so. Good morning. Good morning. I'll just wait for a few more people to show up. We'll just be nice and patient. We'll get started in a few minutes either way, though. Yeah, absolutely. The trig homework that I assigned last week, is that what you're talking about? Set number 3, numbers 3 and 4. Yeah, well, I can start with that. Absolutely. Let's see. Let me just pull that up. Let's go to the website, actually, rather than digging through all my files. 3 sets. Homework set 3. And numbers 3 and 4. Okay. Okay. Well, okay. So some of these are fairly straightforward. Some of them are a little bit more tricky, though. Were there any ones in particular? Like number 3, there's a lot of questions on number 3. Like the first few are, like I'd say the first 6 are fairly straightforward, but then the later ones are maybe a little more confusing. And yeah, number 4, I'll show you. Let's see here. Just give me 1 second. Yeah, okay. Yeah, I was just double checking something about our curriculum. I just want to double check that this is on the curriculum. And yeah, so we don't actually, like, this part isn't a part of our curriculum, so I wouldn't sort of stress out about it too much, but I'll kind of do a few of these. So so what was that question? So this is a problem set, that's not one word, problem set 3. I'll do number 3, and I'll start with just a few of the more straightforward ones. So 3a, we're just being asked what's sine of 0 degrees. Well, I mean, if we look at our coordinates here, sine of 0 degrees, well, 0 degrees is just this, right? And sine measures like the y coordinate of our terminal point here, right? So sine of 0 degrees is, well, 0, right? So sine of 0 is equal to 0. Another thing too is cosine of 0. Cosine of 0, that's part B. Well, that is pretty much, well, it's the same angle, but this time we're measuring how far left and right we go. And the thing about this one is that it we're measuring like the x coordinate, and here the cosine of 0 is actually just equal to 1. So I guess what I'm trying to say is that so these ones, I mean, I kind of skipped a little bit of the book that I'm following along, because I am trying to follow our curriculum as closely as possible, and this isn't actually on the grade 10 advanced curriculum. So like I said, I wouldn't stress out too much about these questions. I'm sorry that I included them. That must have been a mistake, but I think they're still good questions. So I mean, one thing that we didn't really cover is the unit circle. So just to give you a sense of how this works, we kind of looked at how circles and coordinate planes sort of how they have some connections. You can think of all of these sine and cosine values as the x and y coordinates of the terminal point, where the radius of this circle, the radius, is equal to 1. So if that radius is equal to 1, then the x and y coordinates of this terminal point right here, that corresponds to the sine and cosine values. So I guess what I'm trying to say is that I guess we don't have to worry about it too much. I'm kind of surprised that I included that in your homework. That must have been a mistake. I guess I thought that they were all like multiples of 90 degrees. I just looked at the first few and they looked pretty good. And then yeah, question 4, I'm gonna say skip question 4 because yeah, I didn't show you how to do that. So yeah, we're gonna skip question 4. Yeah, sorry about that. I mean, I would like to have this included in the curriculum, but it's not. So we're gonna skip it because yeah, I mean, you will learn it next year. It'll be a big topic that you'll learn about next year. But yeah, for the time being, we're just gonna skip this. But yeah, I mean, it's really not too bad. You just sort of think about it in terms of a unit circle, and there's some key values that you learn about. But I didn't teach you those key values. So just those are the first ones. Sine of 0 is 0, cosine of 0 is 1. Turns out that there's really only a few values that you have to memorize, but I won't get into it. So I'm sorry that I included that. Yeah, that shouldn't have been on there. Okay, so yeah, let's get started then. It says that we have one viewer, so I guess I'll just talk to you. I assume that it's you, so it's just the two of us right now. But I'm sure other people are gonna tune in a little bit later. It seems as though I'm getting about as many views as I have students, so I take it that most, if not almost all of you are watching after the fact, which is totally fine. We have 14. There's 14. Oh, it says 1 on mine. It says 1 concurrent viewer. Oh, that's weird. So we have 14. I thought it was just me and I mean I don't like saying people's names on the stream, but I thought it was just me and D. Oh yeah, there. I just refreshed the page and I've got 15 people. Okay, yeah. I've just been sitting here waiting. I thought it said I'm not making it. It said 1 person. I was feeling kind of a little bit lonely. Not that you were making me feel lonely, but you know, there's just I thought there was just a couple of us. Okay, yeah, let's get started. I don't know what I mean. I guess I was waiting for more people, but I guess I didn't have to. Okay, yeah, so as for the problem set, okay, I feel a lot better about this now because I feel like I was just telling 1 person not to worry about this. So yeah, for problem set 3, yeah, I'm not sure why I included that. That shouldn't actually be on there. It's not a part of the grade 10 curriculum. It is going to be on the grade 11 advanced curriculum. So yeah, you will learn this. I've just sort of I've been talking with your grade 11 advanced teacher recently, and we've kind of been discussing, like, you know, I would love to just keep teaching you all this stuff, but then I have to leave some stuff for next year too, right? So this, I would love to just go ahead and teach you all of this, but then that would be one less thing for you to learn next year. So we're gonna learn some more stuff about the sine law today. That's kind of what we're geared towards, is learning about the sine law, and yeah, so that's what we're gonna do. So all right, I feel much better. Am I teaching you next year? No, I will not be teaching grade 11 advanced. I don't think so, anyways. I mean, nothing is for sure. Teachers usually don't get to know what they're going to be teaching next year until sometime in June. So yeah, I don't know the courses that I'm going to be teaching, but I can assume that they will be very similar to the courses that Mr. McIntosh taught last semester, which would pretty much be the same classes that I'm teaching now. So I'm not teaching grade 11 advanced right now. So yeah, as far as I understand, I think Mr. Ferreira is the grade 11 advanced teacher for next year. That's what the plan is, but like I say, nothing is for certain. Just things like with scheduling, it's really complicated, so sometimes things have to change last minute. But as far as I know, Mr. Ferreira will be your math teacher next year. So let's talk about the sine law. Okay, so the sine law. So if you don't remember, if we have a triangle, let me make a nice looking triangle. So here's a nice little triangle for us. If we have any triangle has 3 sides, right? A, B, and C. And if we name the angles, these angles, so I'll call this capital C, capital A, and capital B. So if those are the angles that we have, so this is our angle C, that's our angle A, that's our angle B, then the sine law, it's actually one of the more easy formulas to memorize, if you ask me. It kind of just, everything falls into place. The A's stick with the A's. There's very little to memorize here. So the idea is that sine of A over A is equal to sine of B over B, which is equal to sine of C over C. Like, wow, what a nice looking formula. Like, all the A's are with the A's, the B's are with the B's, the C's are with the C's. There's nothing like complicated to memorize here. So it's a great formula, and what I thought we could do today is I thought we could try to derive it. So this is the kind of thing that I would have really liked to do as an activity, you know, getting you guys into groups and seeing if you could figure this one out on your own. So what I'm going to do is I'm going to give you a couple of minutes to see if you can prove this property, okay? And if you would like, I would highly encourage you to, message one of your friends. See if you can, collaborate a little bit with someone else if you're feeling stuck. You can also ask for hints in the chat. But I'd really like us to try to do this one ourselves. So what I'm going to do is I'm going to set us up here, and I'm going to sort of draw a picture that hopefully helps you kind of steer yourself in the right direction. So I'm actually going to erase this. So that's the formula that we want. I'm hoping that we have that memorized by now. So there's one key feature of triangles that are really helpful, and that is the height. Sometimes it's called the altitude, the height of the triangle. And the height of a triangle is completely relative. So a triangle technically has 3 different heights, and it depends on what your base is. So the base of a triangle is usually the side that's like on the bottom half, right? But a triangle is a triangle is a triangle, right? So I could take this triangle and I could do this to it. I guess I've kind of changed the size, but I mean, you get the idea. You could rotate it, and then now this is the base. And in fact, there was nothing about the base that makes it the base. Like, this could easily just be the base. This could be the base as well. So with when you're deciding on the height of a triangle, you have to be cognizant of the base that you're choosing. So if this is our base right here, well, that means that the height is going to be the length of this line right here. So what I'm going to do is I'm going to decide that C is my base, and that means that the height is this distance here. And what's important to know is that this is a 90-degree angle. Trig is big. Yes, trig is very big. So this is the height. Okay, so there's the height of the triangle. Now keep in mind, this doesn't turn the triangle into a right angle triangle, right? Like, this is still just an oblique triangle. Remember, oblique, if you don't remember, oblique means no right angles, right? However, what it does do is it does introduce 2 smaller right angle triangles, namely this one here and this one here. So now that you've introduced the height, you can start talking about right angles. And sine and cosine work really well with right angle triangles. Okay, so that's my hint. So maybe what I'll do is I'll start off by saying, so step 1, prove that, let's say, sine of A over A is equal to sine of B over B. Okay, so this might take you some time, and I really want you to actually try it, right? Like, and I think I say this often enough for you to sort of maybe roll your eyes at me, because you've probably heard it already, and maybe you're sick of me saying it, but I really want you to try this. I can't see you right now, but you can see me. But I am just assuming that you are trying this, and you're really trying to get to the bottom of the problems that I'm giving you, because it is important that you do this, right? You actually do have to try this. So if you're not watching live, then I do encourage you to actually, let the time pass through the video. Don't just scroll to the end, because I will solve it for you. I will show you how it's done. But the benefit of trying it yourself, like, you can't fast forward that, right? You actually do have to try it for yourself. So what I thought I could do is I could give you, let's say 8 minutes. We're going to do 8 minutes for this one, and because my guess is that this is not going to come right away. I mean, some of you might be able to just see it right off the hop, right? I don't think very many of you, like it'd be pretty hard just to see it like that. Some of you might get very lucky and just say, oh, I wonder if I can try this, and then boom, it might work. And then I think some of you might sort of hit a wall, right, and say, okay, I've tried a couple of things, I don't know what to do. So I'm going to give you 8 minutes. Don't hesitate to ask for help from your peers or me, because yeah, this one isn't meant to be like super obvious. When you see the solution, you might kick yourself, because it's not a complicated proof, but it's not necessarily obvious either. So I'll shut up now and let you think. I'm gonna give you a little hint if you're still working on it. Try to solve for h in 2 different ways. Okie dokes. Okay, let me show you how this is done. So this is what I'm gonna do. I'm gonna solve for h in 2 different ways, and I wonder how many people got it. I guess something that's tricky about proofs is that you can think that you've proved something, but also not have proved it, right? There's a lot of logic involved. So yeah, let me show you how I solved it. So I'm going to solve for h in 2 different ways. So I'm gonna split this up into 2 triangles. So here's one right angle triangle, and this right angle triangle, I don't really know what this angle is. Like this angle, who knows what that is? It's part of C. It's certainly less than C. Definitely not bigger than C, but I don't know what that angle is. This angle, however, I do know it's A. I also know H, and I know B. So let's see what I can do. So I could say that sine of A is equal to, well, that's opposite over hypotenuse. Opposite hypotenuse. Don't be confused with the h. H doesn't always mean hypotenuse. H in this case is height. So I've got sine of A is opposite over hypotenuse, so h over b. H over b. And like I said, I'm going to solve for h. So h here is sine of A times b. And I'll just put that in brackets so you don't think that we're taking the sine of a number that's calculated by A times b. Just our order of operations is important here. So yeah, h is equal to sine of A times b. Similarly, I'm going to do the same thing over here. And what you'll find is that the sine of b is h over A. So sine of b is equal to h over A. Or in other words, h is equal to sine of b times A. That's looking good. Okay, so if h is equal to one thing, so if h is equal to sine of A times b, and h is equal to another thing, sine of b times A, oops, I'm putting the brackets in the wrong spot. Let's do this, there we go. Well, then those 2 things, they must be equal to each other, right? Because they're both equal to h, so they must be equal to each other. So let's go ahead and solve that. So that means that sine of A times b is equal to sine of b times a, right, like this. And you can probably see what's going to happen next. I'm going to divide both sides by b times a. So take the a and put it over on the other side, take the b, put it on the other side. So what I get is sine of a over a is equal to sine of b over b. Just like that. Isn't that nice? So not a super complicated proof. Like, it didn't take too long, but you do kind of have to know what to do. Now, you might be saying, okay, well, what about sine of c over c? Well, that can be done very, very easily. So basically what we do there is we just erase this and we find a different height. So oopsies, that's too much. So I go and I'm going to find a different height. So maybe I'll do this side over here as my base, like this. Okay, and let's just say that that's a nice little right angle. Well, we would do the same thing. So we would say, well, in this case, sine of c over b, we would say that sine of, what would that be? Yeah, sine of c is equal to, that would be this, now this is our new h. It would be h over a. And then sine of a would be h over c. And we would do the same thing, and we would end up getting that sine of c over c is equal to sine of a over a. And then we can just throw this into our, we can throw this, what am I trying to do? We can throw this into our little mix here. And so all of these things are equal to each other. So yeah, so that's how that works. So sine of c is equal to sine of a, or sine of c over c over is equal to blah, 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 blah. You know what I'm trying to say. Yeah, and that's how the proof works. So it's fairly straightforward. This is something that I would like you to be able to do. Like this is the kind of exercise that I would expect you to do, like on a test or something, is to be able to prove this sine law. Yeah, I mean, I might as well just go out and say it. This would be fair game of a question to ask on the final exam, is to understand how this proof works and to be able to recite it. And I know that's sometimes frowned down upon, is, you know, reciting things and regurgitating, but I think it's really important to be able to recite a proof. I kind of liken it to reciting poetry. You know, I think that that's kind of an it's not really practiced anymore, but I think it is an important thing to be able to, you know, recite poetry, and I think that there is something beautiful about memorizing a poem and being able to just say it and just to have that as a part of you and to understand something so well that you have it just memorized. And I think the same thing about proofs, that I think it is really important to understand proofs, and part of that understanding is memorizing. Because as you progress in mathematics, especially if you want to go to university, study calculus or any other types of math, a big part of math is proving things. And the interesting thing about math is that there's all sorts of patterns and things like this. And the more proofs that you have under your belt that you really understand and are able to memorize and recite, the easier it is to come up with your own proof techniques. So I kind of liken it to, yeah, like an artist. An artist is usually able to talk a lot about different pieces of art and has a lot memorized about the art of other artists, and that can help your creative process. And mathematics does take a lot of creativity to be successful in it. I think it's one of the most creative subjects, because you have to be able to prove stuff like this, and to be given a problem that you've never seen before. You have no idea where to begin, and be expected to just be able to do it, right? That takes a lot of creativity. So yeah, I think that having some things memorized is really important. And I think that memorizing proofs is one of the most important things a young mathematician can start doing, is to memorize how proofs work, because the proof for this is going to be very similar to proofs that you will see later on in your life. And to be able to understand this proof, I mean, basically the trick to this proof was to find a variable. So we introduced a variable h, right? We introduced this variable h, and we calculated h, or we solved for h in two different ways, right? One, we said that h was, sine of c times a. I mean, the first time we did it with a and b, but the second time around, we did it with sine of c into a, and then we said that h was sine of a times c, and then you set those two expressions equal to each other, and that is a proof technique that is used everywhere. So to be able to understand how this proof works, like really understand, I think part of that understanding is being able to memorize it and to be able to just do it again. And just to understand the technique that was used. In this case, it was to introduce a variable, calculate that, like what that variable is with respect to the other variables in the problem, and then say, okay, well, I calculated it this way, I calculated it this way, these two things are equal, and that's the essence of the proof. So yeah, I would recommend memorizing that proof. It's a great proof. Okay, we've got just a little bit of time left. The next topic that we cover, so we basically have 3 more things to cover for the year. I'll list them now. We have the ambiguous case. Ooh, that's not a 10. We have the ambiguous case for the law of sines. Okay, so we've been learning with the law of sines today. We just proved the law of sines. But there is one ambiguous case that will probably take, honestly, probably about 2 classes to really get to the bottom of. So that's probably going to take us to the end of the week. We have the law of cosines. Okay, we've got the law of cosines. Okay. And then the last thing that we have to do is graphing polynomials. Okay, so those are the 3 things that we have left. Now, we are going to finish this stuff before June 19th. June 19th is our last day of classes. So what I thought we could do, and this is what other teachers have done in this class, kind of at the end of the year, kind of like an interesting sort of topic, like topics, sort of special topic, special interest kind of thing, is to talk about matrices. Matrices. And matrices, by the way, is the plural of matrix. So talk about matrices, how matrices can be used. The thing about matrices that's really cool, and I think that I mentioned matrices a couple of times while we were doing systems of equations. So systems of equations. So yeah, matrices are pretty interesting, and what's cool about them is that it takes something that we already know how to do, and it does it better in exactly the same way, though. So it's pretty neat. I really like talking about matrices. So if we have time, we will do matrices. But if we don't, then our goal is to do these 3 topics. So we're gonna talk about the ambiguous case for the law of sines. We're gonna talk about the law of cosines, and then we're gonna graph polynomials. So I'm gonna hold off on homework today. The next homework set that I want to give you will do the law of cosines, the ambiguous case, and then for the law of sines, and then also just the law of sines as well. So that's what our next homework set will be. So it'll be another sort of triple set, ambiguous case, law of cosines, and law of sines. There will be an assignment coming this week, so today's Wednesday. I'm hoping to have it done by tomorrow, so you can get started on it. I have completed a rubric, but for some reason it's not showing up on my Google Drive. I guess class is pretty much over, so I'm just gonna ramble for a minute. I recently made the switch to Linux. I've been meaning to do this for about a decade. I currently am on Windows right now, but a few weeks ago I just I put Ubuntu on a drive, and I put it into my computer and started slowly but surely moving things onto it. And then I realized that this is, you know, the operating system that actually does work the best for me. So I've been slowly but surely migrating everything over there. And the one thing that I can't do is the thing that I do all day, which is stream. Because this thing, this Elgato thing, which connects my iPad, see, this is how it works. It connects my iPad with the HDMI cable to this, and then converts it to a live stream. Basically what it does is it encodes the video into I guess MPEG-4, so you can just stream it. So yeah, there are no drivers for Linux for this particular model, which I think is criminal. The fact that they don't have drivers available for you know, all of these operating systems. So that's the one thing that's bringing me back to Windows. And I guess so yesterday I was working on this rubric. I was in Linux. I was working on it, and I saved it, and it didn't make it over to Windows. I'm in Windows right now, and I can't access it. So I'm gonna post that rubric today. I just have to turn my computer off, turn it back on again, go into Linux, and then post it there. But yeah, so what am I trying to say? Oh yeah, the rubric. The rubric is fairly straightforward. I mean, it's nothing new. I've kind of told you a little bit about it already. I mean, the gist of it is that we're going to have 4 topics. Topic 1, topic 2, topic 3, topic 4, and then connections. Okay, and that's how the rubric works. And it's on a 3-point scale. So I've always found the simpler the rubric, the better. You know, you can make a rubric with like a million things, and then it just ends up being the enemy, right? Especially when you're a teacher and you have to mark this stuff, and then also you as a student having to follow a gargantuan rubric. But yeah, it's just it's 5 columns. Each one it has a possibility of 1, 2, or 3. And yeah, so basically the way it works, and I'll post this PDF very shortly, so you can actually just read it. But yeah, for topic 1, this would be like if you just did some calculations, like you can demonstrate that you can calculate like the sine of 30 degrees or something like that, or you can do some basic calculations. The next one, for each topic, like all of these are going to be the same, right? Because it depends on which topic you choose. The next topic would be that you can show your understanding, and you can explain your understanding. So you can explain how something works, right? You understand, you get it. I get it, right? You get it. You can explain that you get it. You understand how it works. You get the ins and the outs, and you can explain that. To get 3 out of 3 in a topic, you need to have a very deep understanding of it by being able to make connections to real world applications. Or, so I mean, not everything has a direct real-world application, or at least, you know, some of them might be a little bit esoteric. right? Like some of the applications that we have in math aren't very obvious. So it doesn't necessarily have to be a real world application. It could be how it's used, like how is this topic used in other subject areas, like physics or something, or computer science, or other grade levels. Okay, so like, okay, how does this work like in grade 11? Like we're doing trigonometry now. What's next? What are these things? Like why do we have like the square root of 3 over 2? Like what's relevant about that? Like why did I see that on my worksheet? Mr. Bennett told me not to do it, save it for next year. So that's what it takes to get 3 out of 3, is to say, okay, I can make calculations, right? I can do the first part. I can explain my understanding, like I get it, and I can tell you that I get it, and I can also make real world connections, or I'm able to connect it to things outside of our little cute little classroom, right? So so to be able to sort of go outside of the boundaries of our class. So that's what it takes to get 3 out of 3 in that topic. So all of these 4 topics will be have the same rubric. So I really just filled out one column, and then here I just wrote same, and then connections. So this one here is so like you make a few connections. So if you're like, oh yeah, I know, like when trigonometry has irrational numbers, and square roots and radicals also have irrational numbers, right? Like, okay, great, you made a couple connections. Thumbs up. Then what was I gonna say? Oh yeah, number 2 would be you made connections between all of the subjects. So all connections. Okay, so you made all connections between all of the subjects. But it's not really like coherent. It's like, okay, these 2 topics have a connection. This is what the connection is. And then these 2 topics have a connection. That's what the connection is. But to get 3 out of 3 for the connections is to have a narrative. Right? So to choose, like, that you didn't just choose random topics that you already understood the most about, but the topics that you chose kind of like one leads to another, you know what I mean? So that there's almost like a narrative, so that it's almost like you're able to tell a story. So yeah, it's not so much just like, oh, I'm gonna write a paper. Here's my connections section, and these subjects are connected in this way. So that would get you 2 out of 3, right? That would get you 2 out of 3. But to get 3 out of 3 is to sort of be able to tell a story, or just in other words, like, be elegant about the connections. So it doesn't have to be super complicated. Like, you don't have to, like, write a book or something, but I want there to be some kind of, like, one thing leads to the next naturally. So that's how that's going to be marked. So like I said, I'll post this on Google Classroom in probably within the hour, and if you have any questions about it, of course, don't hesitate to ask. And remember, you don't have to do the project. If you don't want to do the project, you can absolutely do the final exam, whatever suits your fancy. That said, I would, now that the rubric is out, I would start thinking about the project now. So start thinking about which topics you would want to choose. If you want to run anything by me, you absolutely can. Some students have already sort of been thinking about the project and been asking me if they think that this is an appropriate set of topics to choose. And if you want, you could have one of these topics be something from outside of this class as well. So if you're really interested in something that's kind of related to the stuff that we're doing, but we didn't cover exactly, just ask, and we'll see what we can do. So yeah, I am kind of hoping that that a lot of you choose to do the project, because I am excited to see what you come up with. I think that there's a lot of potential here for stuff. So honk. I don't know what that means. So yeah, I'm gonna go. I think I went way over today. So sorry about that. I'll just say Goose has been sneezing. Like, she sneezed all day yesterday and all night. So maybe, I don't know if she's sick or something. But the thing is, I've been sneezing too all day. And they also just cleaned my streets. So I'm thinking that maybe Goose and I have the same allergies. But I don't know. Does anyone here know about cats and like sneezing? Like, is that my aunt is a vet, so I was thinking of maybe texting her and seeing if I should bring Goose in. But the vet clinic that I go to, they're pretty serious about the COVID thing, and like even like when I go and buy food from there, it's like they leave it outside of the door, and then I have to like text them my credit card information. So I don't know if they'd be willing to look at her. So yeah. Anyway, I just thought I'd share that with you guys because you guys seem pretty interested in Goose and how she's doing. And so yeah, she kind of had a bad day yesterday. It's really sad seeing her sneeze because she doesn't really know that sneezing is that bad. So yeah, she like sneezes and then she looks like really confused for like a minute. Because you know, like when you sneeze, you kind of feel another one coming. Like she kind of like looks like this for like about a minute, and she looks really disturbed, and she couldn't sleep last night because she kept sneezing. So yeah, I'm hoping it's not an infection. But I guess if it was, then they would just give her some pills and stuff, and she'd be fine. But looks like she's sleeping pretty well right now. She's just been napping. Here, I'll show you. Yeah, she's just right on top of my records. Yeah, so she's okay right now, and the sneezing is kind of stopped this afternoon, or sorry, this morning. But yeah, yesterday and last night it was pretty bad. Anyway, I'm gonna go. I'll talk to you guys tomorrow. Oh yeah, just say hi in the exit slip if you're still watching. It looks like we still have 15 people, but again, I don't know if that number is accurate because for the longest time it was saying just one person. So yeah, in the exit slip, just say hi. Hello, how you doing? Doesn't have to be anything complicated. I just kind of want to get a number, see how many people are watching. So take care, guys. I will talk to you guys tomorrow. Bye bye.